Alright, hi. This is a video over lesson for the section of 2.6. This is the last section that we will be covering in chapter 2, and then you have a test coming up. And so the things that are checked are the things that you should already have done. If you do not have one of those things done, you are behind, and you need to make that happen. Okay? So I'm on page 12. Page 12 is where we start our notes for 2.6. And 2.6 is all about absolute value inequalities. Okay? And as you can imagine, an absolute value inequality is an inequality that has an absolute value term in it. Okay? And so let's just talk about, for this first part here, it says the inequality, the absolute value of x is less than 2 means, okay, well, if you think about what absolute value meant, absolute value was the distance from 0. Right? So this means that the distance between x and 0, right? Because that's what absolute value means. The distance between x and 0 is less than 2. Right? That's this part, the less than 2 part. But so the absolute value just means the distance between x and 0. Okay, so think about it. The distance between x and 0 is less than 2. So that means that from 0, we can go up to 2, but not including 2. So we can go this way, right? But we can't include 2. But remember when we talked about absolute value, right? We could have also been negative. So we can come over this way, but we're not going to include it, right? Because there's no line underneath there. Now think about it. If you're here, is the distance between where you are, like if you're right here, is the distance between where you are and 0 less than 2? Well, yeah. So as long as you wouldn't have, remember I called them bunny hops. If you could take less than 2 bunny hops to 0, then you're in the right spot. And this is a compound inequality, right? We said that x was less than 2 and greater than negative 2. You could have written it like that, or you could have said, okay, x was less than 2 and x was greater than negative 2. It doesn't matter to me which way you choose to write it, just as long as you write it like that. One of those 2 ways. Okay? Okay, so similarly, this means that the distance between x and 0 is more than 2. And if you're thinking, well then, Bauckham, that's just the opposite of what we got. Okay, it doesn't really matter what number we choose as long as the distance to 0 is greater than 2. So we've already talked about this being the distance that's less than 2. So the distance being greater than 2 has to be everything else. So if we're at 2, we can't include 2. We've already gone to the left. That was when we were less than 2. So everything that's greater than 2 has to go that way. Right? And then same thing the other way. If we're sitting here over at negative 7, well, that distance is more than 2. So that would be included as well. So we can talk about all the numbers that are less than negative 2. And that's another compound inequality, right? That was an or statement. So this was when we said, okay, well, x has to be less than negative 2 or x was greater than 2. Okay, so basically, an absolute value inequality is going to create a compound inequality. And that's kind of what we've already talked about. Okay, so in general, we can summarize this way, okay? If you have an absolute value that's less than a number, so you have an absolute value, right? There's some stuff inside. We'll call it, we'll just make a star because I don't want to confuse you with a bunch of letters. You've got some kind of absolute value in there, okay, something inside, and it's less than C. Of course, C has to be greater than 0. Right? Because if C is negative, that's when we said, well, you can't have negative miles to your house, right? So C has to be greater than 0. Then here's what's going to happen. Okay, so that's similar to what we had here. right? It was less than a number. So if it's less than a number, we're going to be in between two values. So that means that your star, whatever's inside your absolute value, is less than the positive of that number, but greater than the negative of that number. It doesn't matter to me if you write it, again, as two separate inequalities or a compound like that. Okay? Similarly, if you have an absolute value, something that's inside, it doesn't really matter, okay? And it was greater than some value, okay? So that's thinking back to this one right here. Then we have an OR situation, right? And when we had the OR situation, x was smaller than the negative of that number, and x was bigger than the positive of it. So that's what's going to happen. We're going to have our star, okay, whatever's inside the absolute value has to be bigger than the positive, or whatever's inside the absolute value has to be less than the negative. Okay, and you're like, Bauckham, there's a lot of stars and C's on that. I don't really understand what you just said. And so we are going to do some examples, as always. Okay. First, I need to remind you, though, remember this graphic organizer from Chapter 1? These things still hold. So that if the absolute value is not by itself, you have to get it by itself before you can split them up. Okay? So that's what we're dealing with here. So let's look at this. Okay? The first question that we ask ourselves is the absolute value bar isolated? And it is. There's nothing there. Okay? If it is, then this is where we have to decide, okay, do we have an and or do we have an or statement? And right here, it's showing that we're less than a number, so let's take it back here. If we're less than a number, we're going to have a situation like this one, okay? So we're going to take what's inside the absolute value, which is x plus 7, okay? And it looks like we have an and statement there. So we're going to be less than or equal to 2, but then we're going to be greater than or equal to negative 2. And now we just solve like a regular compound inequality. So we subtract 7, subtract 7, subtract 7 from all three sides. We end up with negative 9 is less than or equal to x, which is less than or equal to negative 5. And then we're going to graph, just like we have. So we go to negative 9 to close circle. And then we go to negative 5. That's also a closed circle. And as luck would have it, we're in between those two things, so that works out nicely. Okay? The hardest part, in my opinion, is deciding, do we have an and or do we have an or? Okay? So what you could do is just check, pick a number. But what's a number in between negative 5 and negative 9? Well, negative 6 is in between. So if we tried, okay, negative 6 plus 7 is less than or equal to 2. Well, negative 6 plus 7 is 1, right? And the absolute value is 1. And 1 is less than or equal to 2, right? Let's say you pick 0, because I know a lot of you like 0. So if you pick 0, you end up with 0 plus 7 is less than or equal to 2, which gives you the absolute value of 7 is less than or equal to 2, which means that 7 is less than or equal to 2, and that's not a true statement. So we know that we've shaded correctly here. Okay, that's just how you check your work. Okay, on B, we have to ask ourselves the same question. Are we isolated? And we are. So then what we're going to do is decide if we have an and or an or. And here again, because we're less than the number, we're going to have an and. But there's something really interesting here. Okay, when you have 0, there's not a negative of 0, right? So all you have to do is set it less than that number. You could make an and say, okay, then 8x minus 0 has to be, or 8x minus 11 has to be greater than negative 0, but then you'd realize that that's weird, so you don't do that. Okay, so you only have to do it once because there's only one 0 on a number line. Okay, so then we add 11 and we add 11. We end up with 8x is less than 11. And then you think, oh, it's a fraction, so it must be wrong. But it's not, friends, okay? It's just x is less than 11 over 8. And if you plug that into the calculator, that ends up being that x is less than 1.34. So we go to 1.34 on our number line, which is about there. You have an open circle, okay? And then if x is less than that number, then we go the other way. And I know what you're thinking. You're like, Bacham, but you told me it's going to be a compound inequality. And yeah, unless it's 0, right? Weird things happen with 0. And so if you're ever greater than or less than 0, you're only going to have one option. Okay, and you could pick any of those options over there to see if it would work. You could pick 0, and then check to make sure that your arrow's going the right way. Okay. All right, let's do a few more. I think we could use a few more problems here. Okay, on A, hopefully you see that now you have a greater than sign. And with a greater than sign, that meant an or statement. Okay, so we could have that C minus 1 was greater than or equal to 5, or C minus 1 was less than or equal to negative 5, right? That I just took it back to here. I realized that we had an absolute value that was greater than, so I set what was inside greater than that value, and then less than the negative of that value. Okay, that's what happened there. And so now we solve. We add 1, we add 1. C is greater than or equal to 6. So I'm going to go ahead and graph that. If I go to 6, I put a closed dot, and all the numbers that are greater than go this way. Then if we add 1, then C is less than or equal to negative 4. So we go to negative 1, 2, 3, 4. We put a dot, and we're talking about all the numbers that are less than. And that's what it should have looked like, right? If we have something that's greater than, we had an or statement. So that worked out nicely. That means we did it correct. Okay? Okay, on B. Now let's talk about B. B looks almost like A, except for the fact that we have something that's greater than a negative. And so what this means is the distance that we've got with the difference of 10 and M is negative 2 bunny hops, or negative 2 miles. And hopefully you've learned, especially because a lot of you missed this on the test, hopefully we figured out that you can't have negative distances. So this is one problem where there would be no solution, and that's all you have to do. Right? That's all you got to do there, because you can't have a negative distance. Okay? On C. C is about as hard as it would get for you. Okay? With C, the reason why it's a little bit more difficult is because the absolute value isn't isolated. So we have to do that first. Okay? So we have to get all the things away from the absolute value bar. To do that, we subtract 1, subtract 1. So you've got 4 times the absolute value of 2x minus 5 is greater than 20, right? Okay. And then to get it by itself, we have to divide by 4. Please do not distribute inside of an absolute value. It makes me really sad. Okay, then you've got 2x minus 5 is greater than 5. All right, oh, the absolute value, sorry, absolute value. All right. Now we have to decide, okay, do we have an and or do we have an or? And so we go back here and we're like, we have a greater than situation, so we have an or. So I'm going to do it down here. We have that 2x minus 5 is greater than 5. Okay, I'm going to go back here. Or 2x minus 5 is less than negative 5. Okay? So if we solve these, we do plus 5, plus 5. You've got 2x is greater than 10. And if you divide by 2, divide by 2, x has to be greater than 5. So let's graph that. We go to 5 on our number line. Let's see, this is 0, 1, 2, 3, 4, 5. Open circle. And all the numbers that are bigger than 5. And then if we solve this one, we have plus 5 plus 5. So 2x is less than 0. To get x by itself, we have to divide by 2. So x is less than 0. So then we go to 0, circle, go the other way. Okay, and they should be going opposite directions. Remember, if you have an or statement, your arrows should be going opposite ways. That's still something that we're having trouble with, so don't forget about that. Okay? All right, beautiful things. That's section 2.6. Okay, so let's talk about things in life now. These are all the things that you should have completed. Keep in mind, I've already talked about this a little bit with some of you, but this chapter 2 review, okay, and this review right here, those are two different reviews, okay? They're two different things. There is also, I forgot to put this on your checklist, so you need to add it, please, okay? There is also a 2.6 clever. So add that to your checklist, add a little box down there and write 2.6 clever. There is not a 2.6 worksheet, okay, just a clever, and it is due tomorrow night at midnight. You should already have it up in your assignments, okay? 2.5 was due last night, so hopefully you've done it. Tomorrow is a work day. Wednesday is a work day as well, but we're going to have a little bit of an activity that's going on. So don't leave everything for Wednesday during class because you're not going to have a whole lot of time to do it. And then those two reviews that I've got highlighted up there are a thing. And Friday is your Chapter 2 test. Hopefully I'm back by Friday, but if I'm not, you're still taking your test. So please be good, okay? I hope you're all behaving. I hope you're being nice to the sub. Get to work, friends. I will be checking up on your progress.